Okay, let's graph this, and here, we'll just make it a little bit different. How about that? Let's graph this polynomial. So here we're not practicing our division, we already have it done for us. If we want to know what is happening when x equals 0, we'll actually just plug it in here. So y would be equal to minus 1 squared times 4 times minus 3, so this will become positive, so minus 12. So there's my y-intercept. Okay, x equals 0, y equals minus 12. I can just read the number off the end because it's already in the factored form. Okay, so now that that's out of the way, I can look at my zeros, 1, minus 4, and 3. And this one here, because it comes from a factor that has a degree that's even, we say this has multiplicity 2, and since it's even, we know that our graph is going to bounce. All right, I'll show you what this means, and then I'll explain why it does that by looking at this graph's behavior near x equals 1. Okay, so what's the final thing we need to do? I think we need to pretend to multiply this out in our head. So squaring this would give me an x squared, multiplying by that would give me an x cubed, multiplying by this final one would give me a highest order term of x to the 4. Okay, so this is for very, very large x's. Our graph will be approximated by x to the 4, which means that a positive number raised to a positive value is positive, and a negative number, sorry, not a positive value, an even value, and a negative number raised to an even is also positive. So our end behavior looks like that. There's our y-intercept, and these are our zeros, so we're ready to graph. So we go over here, we find the point x equals 1, x equals minus 4, and x equals 3. Then we note our end behavior, up, up, and our y-intercept, minus 12. We'll just pretend this is minus 12 right there. So it looks like we're going to come down through here and then up. Oh, wait a minute. That's interesting. Okay, so we're going to come down through here. Oh, and then I will be coming through here because this is my 0 that has multiplicity 2. So I'm not going to come through here. I'm going to bounce. So you can think of your graph coming to the 0, trying to get through, but ricocheting off, bouncing off. And this makes sense because then I can head down, I can hit my y-intercept, and then I can come back up. This has an odd multiplicity, so I just pass through, and I meet my end behavior. So that's what my graph looks like. Okay, so let's just confirm that when we do have an even multiplicity, we are going to get a bounce. And we can do that by using our behavior near that 0. So let's look at the behavior near x equals 1. So we said whether I'm 0.99999 or 1.00001 that this factor isn't really going to carry. It's going to be roughly 5, and this is going to be roughly minus 2. So I just go ahead and plug the 1 into every factor that it's not a 0 of, which leaves me this front factor, and then 1 plus 4 is 5, and 1 minus 3 is minus 2. So I can multiply these together, and it looks like y is behaving like a parabola, because I have a squared function here that's shifted to the right one, opens down, and it's very, very steep. So there's my bounce, because once I've plugged in these values, what's left over is a quadratic. If this were a 4, I would be getting basically an x to the 4 turned upside down. So again, it would be a bounce. So without going into this analysis here, we're just generalizing that anytime a factor has an exponent of it on it, we have to be careful. If it's even, then we get a bounce. Okay, if there's no exponent, it's like an exponent of 1, and we behave like a line. We just pass straight through. So even exponents bounce, odd exponents pass through.